Okay, so I now want to welcome Mario Havel, who supports Ethereum core protocol development at Ethereum Foundation, and Ethereum founder and glorified blogger Vitalik Buterin.
Thank you. Okay, very well. Thank you so much for coming here this rainy morning. All of you, Vitalik, thank you for being here. And sadly, Mihai could not be here. This panel was supposed to be originally with actually another Ethereum co-founder, and yeah, I am the cheap substitute. I literally woke up this morning to a message that I'm supposed to run the interview with Vitalik like an hour ago. I woke up. So here I am, and I have a few questions ready, because I was told that layer 2s would be an interesting topic, so I would start maybe with that. And there is a lot of course, there is a lot of things happening. There is, on your recently very active blog, you also touched on a lot of layer 2 stuff, and I would start with maybe a bit high level, a bit of a reflection about the rollup centric roadmap, which when I imagine the ETH research blog post, it's like 2-3 years, I guess. And since then, a lot of things happen, a lot of new rollups popping out. And so my question is about the reflection, like whether at a time, a few years ago, you had this vision that it's going to look like this today, or maybe, because honestly, personally, I'm a bit pessimistic about the way the rollups are maturing. We still have the training wheels. So the question is whether you think that it would take this long, whether there are some technical blockers that you see. I remember around DEF CON in Bogota, you've been speaking about the decentralized fraud proofs, and that's something which I found really cool and necessary, but I think we are also not really closer to that, but please correct me. So yeah, how do you see the rollup-centric roadmap after a few years?
Mm-hmm. Yeah, I mean, I think the thing that went well is that we actually do have a pretty large number of rollups, and they really are trying to do a lot of different things, innovating technologically, innovating culturally, innovating economically, in a whole bunch of ways. The biggest thing that's taken longer than expected is definitely getting to having actual working proof systems. And I think Arbitrum definitely does deserve a big round of applause for just being far ahead of all of the other EVM layer 2s for just getting to stage 1. So let's, it is feeling like the level of maturity of all of these proof systems is going up and up, right? And we're seeing ZK-based systems, different kinds of optimistic systems. I know there's OPZK things that do one-round fraud proofs based on snarks. I saw, Tycho has this design that combines, SGX, and then it's kind of optimistic because in that kind of one-round way where if you disagree with the result, you can contest it with a ZK snark. So it's getting there. I think the thing that I would say is that software does often take longer than you would expect, or rather, the last 20% always ends up taking 80% of the time. And I think that would have been true in pretty much any Ethereum scaling strategy, right? Because if you imagine, Ethereum had taken a full layer 1 sharding approach instead, then as I wrote in my blog post, right, sharding and layer 2s basically are the exact same thing. The only difference is basically who has development responsibility and authority for building different parts of the stack, right? And so they would have had the exact same problems. There would have been years of development and actually getting something as complicated as a proof system, whether integrated into Ethereum. And then if it was optimistic, then that would have been super complex. If it was ZK based, it would have taken all the way up until now, probably plus much longer, because we would not have had so many different teams out there in the community trying different approaches. So I think it's important to just appreciate the extent to which scaling that's not multi-sigs is just a fundamentally really hard problem. And it's a hard problem that like basically like any ecosystem eventually has to brush up against and does brush up against, right? So I'm generally impressed by the level of sophistication of the work so far, and like I definitely feel optimistic that we're going to actually like start to see the training wheels shrink and come off over the next couple of years.
Awesome. This is great to hear, being optimistic. And speaking about this exactly, the optimistic ZK world, I often hear ZK everything, or I mean, I see it in the roadmap, ZK everything is the end game. Also, the optimistic people speaking about eventually transitioning to the ZK. And I have basically two connected questions about this. Like, how do you, like whether this evolved for you as well, whether you see the end game in the ZK different than before, and how this transition can happen. What I'm wondering, we have these T-shirts here, whether this can include privacy, because many of these, whether rollups or generally the ZK technologies on Ethereum, focus the ZK on scaling, but don't utilize its properties for privacy. So I wonder whether you think it can be combined, or can be,
I think, so regarding ZK for scaling, I think my picture on the end game definitely feels much clearer than it felt about 3 or 4 years ago. And basically, the end game is what I've called the proof aggregation singularity, right? Which is basically that ultimately, I think an Ethereum block should contain one proof. And that proof is a proof of a bunch of proofs. Those proofs can also be proofs of a bunch of proofs. And you have different levels of proving all kinds of things happening, whether it's inside of L2s, whether it's at the consensus layer or whatever else. And then finally, all of those proofs get aggregated into one, right? And if you do this, then you could have a world where every layer 2 securely commits into Ethereum in every single slot, right? So, today the status quo is like, 7-day delay if you're an optimistic rollup, and then something like 1 to 12-hour delay if you're a ZK rollup. And a big part of, well, there's basically two reasons why, right? One of them is prover latency. And that's just like a prover architecture problem. Once provers have more parallelizability, I think there's nothing fundamentally stopping an EVM block from being proven within 3 or 4 seconds. And the other big piece of this is the fixed cost, right? Meaning especially the fixed gas cost of having a proof that gets verified on chain. And if we have good ecosystem-wide aggregation layers, then we'll be able to move from every layer 2 needing to submit a separate proof to all the layer 2s together really only needing to submit one proof. And once you get into that world, then committing in every single slot actually starts to become much more viable. And the other nice thing about this world is, getting back to the privacy topic again, that's also a world where privacy becomes much cheaper and much more viable as a byproduct, right? Because the status quo is basically, I use Railway, and Railway is great, but Railway is expensive, right? And like the fees are something like, tens of dollars, I forget, is it like 50 or 80 or like some pretty crazy number. And ZK snarks really are expensive. But if we have proof aggregation, then that exact same proof aggregation can also be used to aggregate these snarks that are being used by privacy protocols. And they can also be used to aggregate snarks that are needed for key store rollups. And so account abstracted cross layer 2 becomes much more efficient. And they also enable a different kind of privacy strategy, which is general purpose stealth addresses, right? So I think if we can actually build this, the infrastructure to make this like ZK proof singularity happen, then like that actually makes a whole bunch of problems a lot easier.
That's exciting, and it actually leads me to two questions. First, a bit more technical, something coming from the recent interop, where we saw a discussion about how the Verkle trees, the coming vector commitment Merkle tree transition is going to, what effect it is going to have on the ZKVM and ZK proofs. Some people being worried that it might not be ideal, and actually speaking in favor of binary trees or maybe some other solutions. So, yeah.
Yeah, no, this is actually a really fun rabbit hole. We ended up talking about this quite a bit at our developer retreat in Kenya a couple of weeks ago. So basically, the situation is, right, that we've for a long time wanted to move from hexary Patricia trees, which are just like horrible, ungodly infrastructure that I regret ever creating. And like, they're really horrible, okay? So like, can you guess what is the theoretical worst case size of a Merkle proof needed to prove all of the accesses in a block, in an Ethereum block right now?
Dozens of megabytes, maybe hundreds?
Over 300 megabytes. I think about 400.
Okay.
Now, it's why, right? First of all, because in a hexary Patricia tree, every layer of the tree is 500 bytes because it's 16 hashes. And the second reason is because code is not even Merkle treed. Code is hashed, right? And so if you access 24,000 bytes of code, then your Merkle proof just like has to contain an extra 24,000 bytes, right? 24,000 bytes for the code plus 4,000 bytes for the branch, 28,000 multiplied by, I think it's like 14285 maximum accesses in a block, and you get your 400 megs, right? So this is not like a necessary property of Ethereum. This is like the result of just extremely bad design choices that were made a long time ago. And they don't just hurt Merkle proofs, they also hurt like our ability to increase the maximum code size, for example, right? And so for this reason, we've wanted to switch to a Verkle tree. Verkle trees are based on elliptic curves. And the nice thing about Verkle trees is that even though the arity of the tree, so like the number of children that each node in the tree has, actually gets bigger, it's 256 instead of 16, the size of a proof for each level, instead of being the entire level, it's like one object for each level, right? And so instead of having like a 16 object tree where the proof is 32 times 16, you have a 256 object node where the size of a proof is just 32, right? And then so then a path from a root to any single object is only like about 200 bytes, and then you have an extra single proof that verifies that all of those relationships between the parent and the child node are correct. And basically the size, the worst case size of a proof, if you include both the tree itself and you include some of the changes to the gas costs that accompanying it, like basically charging per chunk of code that gets read instead of charging once for the entire code, then the maximum size goes down to, I forget the number, but we can reverse engineer it, right? Because a branch costs 1900, 30 mil divided, or I guess 1900 if it's in the list, 21, well, we'll stick with 2100, 14,285 multiplied by 200, and it's only about like 300 kilobytes, right? Now, so it's really actually, hold on, sorry, did I say, no, it's not 300 kilobytes, it's about 2.5 megabytes I meant to say, sorry, I forgot a factor of 10, but it's still, like 2.5 megabytes is very tolerable because the theoretical max size of an Ethereum block today with just call data is I think it's like 2.8 megabytes, right?
Including blobs.
Okay, sorry, if you add blobs then it becomes 3.4, but it's, basically, like Verkle trees are just like a really big and really amazing improvement in that way. But the challenge is that Verkle trees depend on elliptic curves, and we designed Verkle trees around elliptic curves because 2 or 3 years ago, in part because 2 or 3 years ago all of the proving systems used elliptic curves, and so Verkle trees were kind of very native to being proven inside of ZK VMs. But then since then, the ZK prover universe kind of decided to mostly give up on elliptic curves, and everyone started talking about the small fields. You have your Goldilocks with the 64 bytes, and then a bunch of other people are like, yo dog, I heard you like small fields, let's do 2 to the 31 minus 1. And then other people are like, yo dog, let's do 2 to the 27 plus 1 times 15. And then eventually these Binius people are like, the numbers are decreasing. How about we just go all the way down to 2, right? And basically, elliptic curves in this kind of world just no longer have an advantage, right? And actually directly proving elliptic curve-based Verkle proofs with these new proving systems actually puts you at a disadvantage, right? So that's one argument. And then the other argument is basically that like these new provers, they're getting so fast that we might as well just like skip Verkle and go straight to binary. And if we go straight to binary, then we have quantum resistance from day one, and theoretically, we never have to touch the state tree again, right? Which is like a really amazing outcome, right? Because like if we can switch over the state to binary, and then we switch over everything else to binary with SSZ, we basically have like one hash scheme to rule them all. Like Ethereum becomes a super beautiful and super clean system on a pretty accelerated schedule, right? And so there is this big desire to try to like see if Verkle can be skipped. The challenge though is that we're still not at the point where we can do that efficiently enough, right? Basically, the theoretical max number of hashes in one of these binary proofs would be that like a prover would have to prove over is like 1 to 500,000. And the best provers that we have, they prove like low thousands of hashes per second. And so, and then like the, actually, proving over Verkle proofs is like crazy fast. There's someone who used GKR, which is one of these fancy schemes, to prove over it. Sorry, GKR is like an elliptic curve-based fancy scheme. So the elliptic curve people are like trying to keep up too, right? And it's like just crazy fast. Like the numbers on Verkle short term are just super favorable. And so one of the questions is like, do we do Verkle first or do we just skip it? And then the other sub-question is like, do we prioritize Verkle or do we prioritize like say 4444 and a couple of other things, right? So the current path, I think, is that we're like really accelerating 4444, really still going forward on Verkle, but at the same time trying to be agile about those things, right? And like I think the nice thing is that most of the work on Verkle, and like I would say maybe 75% of the work on Verkle and like 100% of the work on Verkle that's being done today is actually not Verkle specific. It's like specific to proof formats, infrastructure, transition logic, gas costs. So it's like a bunch of different stuff that is going to be exactly the same even if we throw Verkle proofs away, right? So even if we decide to like flip that switch and switch to a binary system, like all of people's hard work mostly like stays, right? So I think either way we're in a good place, but it's like it's definitely one of those fascinating technical debates, and I think it also shows the importance of kind of maintaining agility and like basically constantly rethinking pieces of the roadmap and basically saying let's look at the actual situation that we have in 2024 and let's like make sure is the thing that we wanted to do 3 years ago still the right thing, right? And like sometimes it is and sometimes it isn't, and like if it isn't, then we do need to be open to pivoting.
Thank you so much for guiding us through the rabbit hole, catching up on months and years of core R&D, basically, with this explanation. That was quite technical. I love that personally. I'm not sure if everyone's following though.
Who here likes rabbit holes?
Binary or Verkle? Oh no. Before we have a few minutes, I was told. So. A bit less technical topic maybe, more about the culture that you've write about recently. So one thing, okay, so yesterday I saw a tweet from Guard saying something like, Vitalik is the only co-creator of a cryptocurrency, a part of Satoshi, which got ETF, and he didn't say anything about it, which is respectable. And I don't want to ask about that. I don't just like. I still don't want you to say anything about it, just that with these ETFs, with CBDCs coming to maybe Ethereum or similar chains, with so many, whether government or just many other actors coming to this technology, do you think it might be harder to maintain the Ethereum culture, the cypherpunk culture, for example, more practically in enshrining privacy or censorship resistance features?
I think, I mean, Bitcoin, does have a strong cypherpunk culture to it, and I think that is one of its advantages that's really worth recognizing, right? And I do think that kind of Ethereum's positioning has always been that, we take the kind of golden mean between being Bitcoin-like and being one of these sort of fast chains that doesn't really care about decentralization and just says like, go, 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 we're going to degen and scale. And I think this does also mean that Ethereum has this kind of always this constant, cultural choice of kind of do you go in one direction or do you go in another direction? And like, I actually, I feel like it's, over the last year, the mood has been kind of going a little bit more Bitcoin-y. I think, I think in part because, we just realized, right, that like there's, fast execution layers, like there's lots of people that are making them, and, there's even amazing, teams and, even, teams in this room that are making, really amazing, like fast chains that as part of the Ethereum ecosystem, right? And, if for Ethereum to, there is benefit in kind of like specializing in like being that kind of like secure core. It's and like there definitely is going to be pressure to try to like ossify things, and there's going to be lots of pressure from a lot of different groups. On the question of privacy, I think. A big part there is like, there's always been this kind of debate of like layer 1 versus layer 2 privacy. And Ethereum has generally taken the layer 2 privacy route. And I think generally not because we don't believe in privacy or like we think privacy is optional, but because there's just like so many different technologies for getting privacy, right? Like you have GPHR 13, you have Groth 16, you have Plonk, Plonky 2, Plonky 3, Goldilocks, you have Halo, you have, Calc, you have Merkle tree proofs, you have joint split protocols, you have Aztec VMs, you have like at least 2 different philosophies of how to do privacy pools. You have just like a whole bunch of these different things. And it just always felt too early to like really enshrine one of those, and like it felt against Ethereum's philosophy to try to enshrine one way of doing privacy when Ethereum was all about enabling multiple ways of doing everything else. But the thing that Ethereum did do early on, right, is we did quite early on add the elliptic curve precompiles, right? And the elliptic curve precompiles were added specifically with the goal of making privacy protocols possible, right? Actually, using elliptic curve protocols for ZK rollups, like that actually came after, right? That came in 2019. The original reason to put ZK or elliptic curve or BN128 precompiles into Ethereum was to support privacy features. But then, it is possible that Ethereum's approach is going to change over the next couple of years. The reason basically is that like our ecosystem is moving from like indefinite optimism to definite optimism to some extent, right? Like, if you remember 5 years ago, it was like, let's get excited about everything. Do you like stable coins? Yeah. Do you like DAOs? Yeah. Do you like ENS? Yeah. Do you want to turn everything into a DAO? Yeah. Do you want to have prediction markets? Yeah. Should the prediction market be a DAO? Yeah. Should Ethereum, do ZK? Yeah. Should we do sharding? Yeah. Should we do hypercube sharding with like an arbitrary number of layers? Yeah. And then, it's okay. Okay, but. But over the next 10 years, things have kind of matured, and like we have like a much clearer understanding of like what actually makes sense in terms of things like scaling, in terms of technology choices. Even in terms of applications, and like we talked about the proof singularity, for example, right? And like there is a lot of value in enshrining some kind of proof aggregation eventually as part of the Ethereum protocol, right? Because whenever you do something as a layer 2, especially if it's an aggregation protocols inherently have fixed costs because it's like, no matter whether you have 50 people on the bus or one person on the bus, you still have to pay for the whole bus and you have to pay for the whole driver, right? And so like the economics of that are like very unfavorable, and that's actually a big, like part of the reason why like public transit systems often end up subsidized, right? And so having like protocol layer buses for proofs is something that I think is like just from an like economics perspective is something that's worth eventually considering. And when we do that, that would mean that like we'd have to pick a particular proof system, right? And I think having like in protocol features that are organized around like even like privacy needs in a more explicit way is like something that could totally happen, but like that's the choice for Ethereum's future and the community of the future. So it's one of those discussions that I think it continues to be worth having.
Yeah, awesome. Thank you so much. I think we have to wrap up.
Okay.
Are we out of time, or we have?
We are pretty out of time.
Okay. No more questions though. Thank you so much. Many rabbit holes that we looked into. I really appreciate that. And yeah, I guess that's it. Thank you so much, everyone. Yeah.
Thank you both very much. We're going to take just a couple of minutes. We'll be back as soon as we can with our next speaker.